Today, my name is Alan Chang. I'm representing Inspur to talk about sustainability. And first of all, I think sustainability has it's like a main thing for this conference, and there's a different approach to it. As far as for Inspur goes, I want to make this more like a communication committee, like share about what we think and what we see in terms of the talking to the customer, and then bringing in some awareness of some of the things you might have missed. So my agenda is obviously liquid cooling for all. I think on the booth, you see a lot of different technology, different approach on how to do liquid cooling. But I would say until like some of the hyperscaler really adopted liquid cooling, like a lot of cost situation and things like that is not gonna making a lot of sense to you guys. So I think that's one of the things I want to bring into the awareness. And then when you're selecting a different vendor, what do you need to pay attention to, right? Some small detail and things like that. And of course, common building blocks is going to be my second topic about how vendors like manufacturing OXM like us, how do we make sure we can reuse some of the building blocks without, creating all these different SKU, riser cars and things like that, which create a lot of waste, right? And then how do we do that in terms of the approach? One of the things that hasn't been done in the sustainability conversation is DCSCM. It's a modularized BMC, and how do we see that as one of the very important conversation about how it will impact the sustainability part of it. So let me kind of get started from the really, really easy ones. Like, what's liquid cooling, right? I think in the past 3 years or so, everyone or starting to talk about liquid cooling in their data center as one of the options. But before that, everything was air cooled. Right? You're talking about CPU about maximum out at 165 watt, right? But right now you're talking about CPU potentially mixing out at 355 watt, 400 watt, or even higher. We're talking about some of the GPU is reaching 400 watt, 500 watt, or even potentially 600 watt down the path. So realistically, right, air cooling is not sufficient enough to cool it down. So that's why the liquid cooling conversation become a topic. And of course, different company like you talk to has different approach, and they will talk about different benefit of all that. But in essential, there's a couple building blocks, right? You want to have like a CDU kind of thing. You want to have a metaphor, and if you go into even more aggressive to immersive cooling, right? You're talking about a tank like with the immersive liquid that you can actually immerse your server into it. So essentially, that's all the different building blocks you have to consider when you're building a liquid cooling solution for your appliance for your application. So there's a lot of moving parts, right? Don't make it wrong, right? It's a journey. You have to actually take it one step at a time. So there's some misconception when I'm talking about liquid cooling to my customer. It's the first thing first. Hey, I'm not running HPC. I'm not using the highest TDP CPU in the world. So should I and do I need liquid cooling? And my answer to that is, it depends, right? Like, do you have a power limitation on your rack? And do you want to save energy, right? Do you want to save electricity? And then do you have a limitation of the power per rack, like 12 kilowatt, 8 kilowatt, and you want to save as much power as possible? That's one of the things to think about. And then, of course, when you were able to apply liquid cooling or some sort of liquid solution to the CPU, it doesn't necessarily to be the highest TDP CPU. You can actually use a middle core CPU and then able to reduce the fan speed, which you can save, right, some of the fan power that's going to the server. I'll have an example, a very straightforward example that allow you to understand that. And then once you apply some sort of liquid cooling solution, it actually reduce the fan with a lot of moving parts, right? Being spinning too fast and things like that, you actually increase your MTBF, mean time between failure, for the server. So you might able to, I don't want to say reduce headcounts, how many people have to manage the data center, but like you could be having less incident about fix and break, right? Like you don't have to fix the server that many times. So let's start with the conversation about how you potentially can increase the compute density per rack, right? In a situation like this. So on the right hand side, you have a 4 server inside that particular rack. This is a reference about a 12 kilowatt rack, which is very standard in the industry today. And so my customer having a 2U40 compute system, right? A lot of compute power. And then what they were doing is, hey, they have a 12 kilowatt power limitation, right? Or even 8 kilowatt power limitation. And they don't want to put as much compute as possible. So what they did is they apply a cold plate liquid cooling solution to it. And then they were able to reduce the fan speed to a substantial, very low speed, and then save about 300 watt, right, on the fan power. I was seeing an example earlier on the expo. Someone was talking about GPU, right? The fan speed could potentially be 2,900 watt or something like that, right? And then you can actually reduce that to 900 something watt. So you can have a very significant saving when we talk about GPU applying the liquid cooling solution. So they were able to reduce that 300 watt about a system, and then saving about 1,300 watt. So they could potentially put in one more system in the same power limitation that they have. So they actually essentially increase the computing power in that particular rack just simply by applying some sort of liquid cooling. So it doesn't necessarily have to be HPC, just simply you want to have apply some sort of liquid cooling solution. So one thing to know about is OCP this particular year has a new charter called Cooling Environment. I think if you're not aware, it's a combination of 5 different subgroups that was before this time was working on a different project, and then they combined it for a cooling environmental charter. And then Inspur is very happy to be part of this, and then we're working with a lot of different partners, continue to work on that. So a lot of expo talk about inside the data center, right? You have immersive cooling solution, you have like metaphor, you have all this stuff, right? What happened to the outside, right? What do you have to have outside? And then maybe part of the innovation is you have to have a cooling tower, water pumps, and all this stuff, right? It could require you to actually build something extra on your existing infrastructure. So Inspur, as part of the solution provider today, we're actually having a turnkey solution that allow you to having all this, like red circle stuff, the water pump, the cooling solution, actually have a turnkey solution to install into it. So you can actually essentially retrofit your current infrastructure to become liquid cooling capable. So I think that's important to understand too. So it's not just what happened inside a data center, right? What happened outside of it, you also have to find a solution partner to work with you with them. So of course, once you start your liquid cooling journey, you will want to start on maybe a POC, modularize it a little bit, and then start expanding to it. So we have all this customization portion of it that can help you to achieve that goal. So when you're choosing a system integrator or a supplier who is actually building the journey with you, you want to make sure they have the capability of delivering something, either the entire rack solution, right? If you're buying everything in the rack level, of course, that's great. But I do have a customer who is buying a system pizza box level. And then that will require the supplier or system integrator to actually have a liquid cooling factory. And I'll explain why that's important, right? And then Inspur happened to have that factory capability, and then we're able to deliver that in what we mean a complete system level. So let's look at this. Look at the flow chart. So this is a traditional manufacturing process for most of the system integrator out there, right? You have a chassis, you have a material, you have a motherboard, you start putting everything together, right? So what's really important is when you have applied some sort of cold plate solution, you have the cold plate inside the system already, you want to inject liquid, right? So the burn-in inspection, you have to have the system running 24 hours, 36 hours, 72 hours with the burning process with the liquid. Just make sure when you have heat going up and then the water pipe, the cold plate was working as expected. Once you have done that, one of the things is like, how do you get those water out, right? How do you get those liquid out in order for logistic? You have to dry it up, right? Basically what you happen is you want to drain and drying the liquid out of the system, and then you have the nitro filling to actually everything was completed getting out of the system. So when you receive it, it's brand new as it is, and then you just have to apply the liquid cooling on the side for yourself. So I think these are the equipment and then process that was in additional to what you have known as the traditional manufacturing for server, right? This is in addition to, but it's essentially very important. You don't want to have a partner, right, who is building a server liquid cooling and didn't test it, just actually have the system installed. but never test the liquid and then dry it out before they ship it to you. What happened in the data center might not be what you really want to expect it. So we have been deployed a lot of successful stories. So for the interest of time, sorry because I'm late, so I'm gonna skip some of the cases, but we have been having a lot of successful story to actually working with some of the really big partners out there. All right. Let me change the tone a little bit as a common building block, right? So a lot of innovation you see in the OCP community today is for hyperscaler, right? But you have to ask yourself, are you ready for the hyperscaler stuff, right? They are buying thousands or tens of thousands of servers every month or every single year. Are you at that scale, right? So what happened is all this genius engineer effort that was putting into the OCP summit, what Inspur was trying to do is actually make a conscious decision. We want to continue a pizza box revolution, right? We want to take all the fun factor, the good ingredients that OCP has provided, and then put it in the pizza box. That's the lowest entry barrier adoption for everyone, right? So we started a journey about 2019, having a 4-socket platform. We continue to invest into that, and then we have the second generation of the 4-socket platform in the pizza box is accepted by OCP. And then we're working with Samsung in 2020 for the what they call the Poseidon V1 with the storage box. And we're working in the V1 spec and then have a product ready. And then this particular year, we have a V2. So it's part of the continued investment to make sure there's innovation continue to happen in the pizza boxes. And what's important for the sustainability of this is, so what happened is like we were having a general enterprise base spec, and we actually used that to develop 3 different motherboards, AMD, Intel, and Ampere, to fit it into the same chassis. So what happened is a lot of waste, right, in the industry today is you have to create this sheet metal, and then you create a lot of wastes, right? And then we kind of reinvented ourselves every time, right, because we have a different silicon. So what happened is we make a conscious decision saying, if we could leverage the same chassis form factor every time, and then have the common motherboard form factor. So that will help support, is it coming up? Yeah, okay. Oops, it's checking. Yeah, there you go. All right, so I'm sorry about the screen. But basically, what we did is using the same chassis form factor, having 3 different silicon motherboard, AMD, Intel, and Ampere, all fit into the same chassis. So it's part of a sustainability effort that we want to do to reduce this tooling effort and then reduce the waste of creating this tooling. So as far as for the community goes, right, there's a DC MHS module. So that's one of the efforts we want to combine with the rest of the community, right? Can we actually have a chassis that's going to be sustainable across different OEM vendors, and then we will have shared that throughout a different generation and so forth. So I think that's a combination of effort that we want to put together. All right. So for my last topic, if you're not aware, there's a DCSCM module that was actually created to, initially it's kind of open source up the BMC source code, right? But the way I'm looking at this is most of the OEM, maintain their product life cycle for about 5 years. Once we sell it to you, and once the silicon was available, we sell it to you for 5 years, and then we stop kind of maintaining the firmware sustainability, right? We don't rebuild the firmware stack. But what happened is these servers are as good as it can go, right? Still working, but because the OEM is not sustaining it, does it make sense like to throw them away? I don't think so. So the effort is, Inspur is committed to ourselves to have an open BMC source code using the community code and then build it from the ground up, so we will contribute back to the community. And then if you're buying from Inspur, let's put it this way, even though Inspur stopped supporting the software refresh after 5 years, you own the code, and then you can still actually have that effort to maintain it yourself. You can actually refresh that and to have bug fix and things like that, security patch, as long as you want it. So I think this is one of the effort I feel might get missed by the community by saying, hey, how does DCSCM could be a sustainability topic. So I think ourselves is committed to that. So if you go to our booth, all our future generation of the server will be DCSCM ready. All of them is going to be capable of installing a DCSCM module. Right now it's 1.0, but we're working with the community to actually adopting 2.0 as we speak. So I think that will be something as part of the commitment for the sustainability topic. So that's kind of everything I have. I'll stick around, and I know I'm sorry about being late and then also about flickering on the screen, but I'll be around and then answer any question for that topic. Thank you. Thank you, guys.